Hey guys! So here we are, Chapter 2, The Chemistry of Life. We are going to talk through this a bit. We're going to do some post-it notes. So let's not delay. Let's just get started. Section 1. Atoms are subatomic particles that are made up of protons, neutrons, and electrons. Atoms are also the basic unit of matter. So protons have a positive charge, neutrons neutral, no charge, and electrons have a negative charge. Here we have a model of an atom. Protons and neutrons are in the center of the atom, and floating around the outside on electron clouds are electrons. Now, the nucleus is what the center of this atom is called. The attraction between these protons and electrons is what holds the nucleus into that cloud. And generally, atoms have equal numbers of protons, neutrons, and electrons, which gives them a zero net charge. Elements are pure substances that consist entirely of one type of atom. Alright, so here we have an element, okay? Different elements have different numbers of protons. Mass can be determined by adding the protons and neutrons together. So here we have 6 protons. The atomic number of this element is 6. Let's see next. Isotopes are elements that have the same chemical properties but different numbers of electrons. So for example, these are all carbon, but they have different electron numbers, which is denoted by the different numbers here. These are, carbon-14 is radioactive. This means that it has an unstable nuclei. It gives off extra energy by giving off alpha, beta, or gamma rays. The difference here is the difference in the number of neutrons. This also gives it a different mass. So different number of neutrons, these numbers here, are the different mass numbers. A chemical compound is a substance that is formed by a chemical combination of two or more elements. The physical and chemical properties of compounds are normally pretty different from those of the elements that it was formed from. So, chemical compounds are combined by bonds, and they store energy in those bonds. There are a few different types of bonds. First are ionic bonds. These are formed when one or more electrons are transferred from one atom to another. So an electron is being transferred here, and you can see that in the numbers. So this electron number 11 transferred over here, so it decreased. Now it has 10 electrons, and this one gained 1, so it has 18 electrons. This transfer causes this to be an ionic bond. The positive and the negative charges attract to form that bond. Covalent bonds are formed when atoms share electrons. This is really kind of blurry, isn't it? Let's see if we can focus better for you. Seems to be a bit better. Okay. Covalent bonds, electrons are shared. So this hydrogen and oxygen are sharing these two electrons. There are 8 in oxygen, and in total there are 10 here. Water uses covalent bonds as well, but we're going to talk more about water in the next section. So, section 1, you can pause now until it's time to move on to section 2. And here is section 2. So, section 2 is properties of water. Water molecules are polar. This means that they have an unevenly distributed charge in their molecules. There are more protons in the center. This will actually be a better picture for you. There are more protons in the center here, so the electrons are attracted to those positive charges. This creates a negative pole, meaning polar. Also, that's why the molecule is bent. I'm trying to get it focused for y'all guys. Give me just a second. There, that's better. Okay. Hydrogen bonding. Let's screw this. Hydrogen bonding, right here. Water is polar. It has partial charges. This allows for this hydrogen bonding. It's very similar to an ionic bond, but it's a whole lot weaker. So what I mean here is this hydrogen is positive, this oxygen is negative. The positive and the negative attract to allow for that bond. Now, cohesion is an attraction between molecules of the same substance. Water can actually form up to 4 hydrogen bonds with other water, and this allows for really high surface tension. Adhesion is the attraction between molecules of different substances. Here there is a picture of a tube. If this tube were narrower, then the water would rise higher because there's a larger portion of the surface of water that's actually adhering to the glass. And so you see this little meniscus, this little groove that's formed because water is actually adhering to the side of the glass. Heat capacity is the amount of heat that it takes to raise a temperature. I didn't add that in a post-it note here. Molecules have to move a lot faster for the temperature to rise. Hydrogen bonds make the water harder to move faster, so there's a stronger resistance to temperature. Solutions. Water's polarity gives it an ability to dissolve both ionic compounds and other polar molecules. Water is really versatile because of its polarity. Now, pH. pH is a measure of the hydrogen ion concentration. Low pH, down here, means that something is very acidic. It has a high concentration of hydrogen and a very low concentration of hydroxide. High pH is basic or alkaline. It has a low hydrogen concentration and a high hydroxide concentration. Buffers help maintain the homeostasis of an organism. Weak acids or bases that react with a strong acid or base to prevent sharp pH changes are buffers. Okay, so end of section 2. Next we're going to talk about section 3. Here we have a little bit, a few different images showing carbon structures, and there's a few things that I want to point out. So, in these structures you are seeing covalent bonds. Here, this single line shows that it's just a single bond. This one has a triple bond, so 3 lines. And then this is a double bond, 2 lines. And we'll talk more about bonding later on. So, macromolecules. These are large organic molecules found in living things. When I say organic, there we go. When I say organic, I mean it contains carbon. They're joined together by a process called polymerization. This means that a lot of small pieces or monomers link together to build a larger piece full of many pieces called a polymer. This can happen in 2 ways, either by hydrolysis or condensation reactions. So hydrolysis is when the molecule is being broken down and it uses water. Condensation or dehydration reactions happen when something is built and water is released. Now, carbohydrates. Carbs, living things use carbs as a source of energy and for structural processes. So I'm just going to run through some of the things for carbohydrates here. The monomer is called a monosaccharide. It means one sugar. It is a simple sugar. They work in our body as a short-term source of energy for our cells. If you don't use all of the carbs that you have consumed, they will turn into fat. The elements that it is made up of are carbon, hydrogen, and oxygen in a 1 to 2 to 1 ratio. So this means that when you look at the molecular formula for carbohydrates, you're going to see carbon, hydrogen, and oxygen in this 1 to 2 to 1 ratio. These can be defined by the endings OSE. So for example, glucose, fructose, galactose, those are all carbohydrates. And they offer about 4 kilocalories per gram of energy. Next are lipids. The monomer of lipids are glycerol and fatty acid tails. They provide long-term energy. Your body will use them when carbohydrates are scarce. They're also very good for organ cushioning and insulation. The elements are C, H, and O. There are 2 parts to lipids. There are hydrophobic tails and hydrophilic heads. Lipids can also be either saturated, which means they have no double bonds, or unsaturated, which means that they do have double bonds. And I understand this may be a bit confusing. We'll go into more detail when we do our doodle notes. So these offer about 9 kilocalories per gram. Lipids offer the most energy of all of our macromolecules. Now, in this picture, this is a lipid. Here you see single bonds and you see some double bonds. More bonds means more energy. Saturated fats, by the way, are your bad fats, and I'm doing this in like quotations, and unsaturated fats are your good fats, which means things like salmon, olive oil, avocados, those would be good. Things that would be considered bad fats are going to be like butter, plain, I don't know, like oil that you'd fry, Crisco, frying oil type things. The difference between the two is that the bad fats, the saturated, they will turn almost solid when they are at room temperature, kind of like butter. When that happens, because of the kinks in their bonds, they can clog arteries. Things like the good fats like salmon and avocado and olive oil, they don't have all of those the kinks, so they can't clog together. And I'll describe this better when we do the doodle notes. Sorry for ranting. Next, let's do proteins and then nucleic acids. So proteins, the monomer is an amino acid. Amino acids join together by using peptide bonds, so sometimes proteins can be called polypeptide chains. They are used as building blocks in your body, so they build things like bone, muscle, hormones, enzymes. They're made up of the elements carbon, hydrogen, oxygen, nitrogen, and sometimes sulfur. They can be defined by an R group, amino, and carboxyl group, and again, we'll draw this in your doodle notes. They provide you with about 4 kilocalories of energy per gram. Finally, nucleic acids are made from nucleotides. They're good for energy storage and transfer, and they store genetic information. So they are made up of the elements carbon, hydrogen, oxygen, nitrogen, and phosphorus. They provide no energy and we will draw a nucleotide. These nucleic acids can be defined by these three things. So a phosphate, a 5-carbon sugar, and a nitrogen base. This is the end of section 3. We're going to move on to section 4. Chemical reactions and enzymes. So a chemical reaction changes one set of chemicals into another. It's a change in energy. So here is an example of a reaction. There are reactants. These are the things that go into a reaction. So reactant plus reactant is going to create a product. Now, chemical reactions that release energy often occur spontaneously. The ones that absorb energy require a source of energy. Spontaneous reactions can take a really long time. So there is this term called activation energy. That is the energy needed to get a reaction started. And there are two different types of reactions. There are energy absorbing. These are also called endergonic. The product energy is greater than that of the reactants. The second is an energy releasing reaction. This is called an exergonic reaction, and the reactant energy is greater than that of the products. We're going to focus on this graph. So this is an energy absorbing graph. It can occur spontaneously because it requires more energy to get started. This graph has a lower activation energy. The blue is higher, okay? And this graph will proceed more quickly because it has a lower activation energy. This probably used a catalyst. A catalyst speeds up reactions by lowering activation energy. So enzymes act as catalysts. Enzymes are proteins. They work to lower the activation energy and in turn speed up chemical reactions in your cells. So an example of an enzyme in your body is carbonic anhydrase, and that's what's being shown right here. It speeds up this reaction by a factor of like 10 million. So these enzymes are very specific, and it's necessary for reactions to happen in a very timely manner. We will talk in class about the enzyme cycle. Enzymes have a few different parts. So the substrates are what is being broken down, or sometimes what is being built up. These fit into an active site inside of an enzyme. When this substrate binds at the active site on the enzyme, it is called the enzyme substrate complex. It's going to convert that substrate into products, which are then going to be released, leaving this enzyme ready to work again. These are super specific, like a lock and a key. This substrate will only bind to this enzyme, so that means that this enzyme will only do work on this type of substrate. These can be used multiple times. The only time that this enzyme will no longer work for this substrate is if it is denatured. And they can be denatured by things like temperature, pH, and we'll talk about those more later. So that is all for chapter 2. I will see y'all in class.